Good day, everyone, and welcome to today's training session. This is to officially welcome each and every one of you to this very session of our training course, Solar Power System Installations. This is to officially welcome you to the premium session, to the live class that will lead to the premium session of this training course, Solar Power System Installations. We have been able to teach you guys, walk you guys through, make you know and understand basic reasons why you are here. And up till now, you all should know and be aware of the reasons why you are here. One of the basic reasons is that you are here to get yourself equipped. You are here to uh, gather the knowledge on solar power system installations, and this is the basic course, which means whether you are a beginner, whether you are a new person, whether you are already an installer or a professional in the field, this is the platform you need to join. This is the training course you need to join in order for you to upskill and then become better in the field. Okay, and we are here to make sure that you all become professionals in this field. We are here to make sure that you all become professionals in this field. All right. So for tonight's class, we are going to be talking about system design, system sizing. Okay. We are going to be talking about system designs, system sizing as it concerns solar power system installations. When we say system design, system sizing, what are we talking about? What do we really mean? It means that we have taken into consideration the fact that there are certain things, there are certain questions that some persons will always ask at the end of the training session that we had previously, such that some persons will be asking, what is the size of the solar inverter suitable to power up a facility? What is the size of the charge controller? What size of um, solar panels will be needed to power up that facility and recharge the batteries? And we keep telling you guys that what you need is to have a good idea of energy audit. And having a very good idea of energy audit helps you to be able to know or size these various home not just home appliances, but your solar system sizing as well. So we'll be talking about what we call energy audit. What is energy audit? What does it do for us? How did we come about energy audit? How can we even be able to apply that knowledge on of energy audit? You don't have to worry so much. There might be so many questions on your mind when it comes to the question of energy audit. However, it is not going to be a challenge as long as you are on this our very platform, because we are going to make everything easy for you to know and understand, just as if it is going to be simple as ABC. Okay, so I hope you all can see my screen. Please signify if you can see my screen. Give me thumbs up if you can see my screen. Let me know you can see my screen. Okay, Mr. Isaac can see my screen. Mr. Jacob can as well see my screen. All right, thank you. So energy audit, like we always have it, is divided into two. On one hand, it helps you to know the energy need of your facility, and on the other hand, it helps you to size your various solar components. It helps you to size your various solar components. What does that mean? It simply means that energy audit takes into consideration the energy requirement of your facility by having a good idea or providing you with information of the various appliances that you need to power up using the solar system, and doing a basic sizing on those appliances. It then gives you the information of the energy being consumed by those various appliances. That is what it means by energy need of the facility. The energy need of a facility is rated in watt. It is rated in watt, and therefore um it could be 3,000 watts, it could be 4,000 watts, it could be 5,000 watts, it could just be any size of the quantity of loads that are available to be powered up using the solar system in that facility. On my screen, you can see that energy audit is a determination of the energy requirement for a building. It is a careful examination of the electrical loads. That is what energy audit is. It tells you two things: helps you to know the energy requirement of the facility, gives you idea of what you're powering up, at what time are you powering those things up, and how long do you want it to run. Now, when you know the energy need of a facility, by knowing the various appliances and the energy those appliances are going to consume from your solar system, you then use that information of the energy need of the facility to size your various solar components. So that simply means that if the energy need of your facility is, say, 3,000 watts, if it is 3,000 watts, what you now need to do is that you are going to be using 3,000 watts to size your inverter system. You use 3,000 watts to size your um, battery system, saying that what capacity of inverter system can be able to power up your facility, which is that 3,000 watts. What size of battery or capacity of battery can be able to power up 3,000 watt worth of load, depending on the backup time, which is how long you want that system to run. You also use that your energy need to size your solar panels such that you will be taking into consideration the capacity of solar panels that will be able, reasonable, efficient, sufficient, enough to generate that required amount of current, of not current this time around, required amount of energy, which is to power up that your facility and also recharge your batteries at the same time. So energy audit does a whole lot of things for you. It does a whole lot of things for you. Energy audit helps you prevent oversizing of your system. It helps you to safeguard your electrical appliances from damaging, and it also generally saves you costs. This is basically three things that energy audit does for you as not just as a client or as an installer. It does that for you even as a professional in this field. So that simply means that with the knowledge of energy audit, you are now trying to put things together such that oversizing of your system would be taken care of once and for all, and that will save you cost. Now, three things that energy audit is doing for you right now, as you can see on my screen. It is preventing oversizing of your system. It is also safeguarding your home appliances and your solar system as well. And it is also saving you cost. Now, let us connect the act of saving you cost to preventing oversizing. Let's say, for instance, our client for tonight. Let's say somebody here is our client for tonight. Let's say Mr. Who is going to be our client. Okay, we want to choose somebody who is going to be active. Okay. All right, so let's say Mr. Jacob. Let's say Mr. Jacob is our client for tonight. So Mr. Jacob being our client for tonight, he has simply means he has contracted us to come and run a solar system for him in his facility. So if we do not have good idea of solar energy installations or solar system designs, we might make a whole lot of mistakes. Yes, we might make a whole lot of mistakes by assuming alone would cause a whole lot of problems, a whole lot of challenges if we just decide to assume. And that is why it is highly prohibited that solar installers assume in this field. You are not allowed to assume. So if Mr. Jacob invites us for a solar system or reaches out to us for a solar system installation project, and we do not carry out a proper load audit, energy audit, or even analysis on that facility, and we just have idea of what he wants to power up. Maybe he wants to just power up one television, two bulbs, and his laptop, just basic loads. And we say, okay, go ahead and install 10 kVA. That 10 kVA is going to be powered with 15 kilowatt lithium battery, and we are now making provision for 10 unit of 580-watt solar panels. Have we done the job Mr. Jacob contracted us to do? Yes. But have we done an excellent job for him? No. Because on the long run, another person, another technician, or a more professional would get into that facility, or the person might even actually be Mr. Jacob's good friend. And when he gets to Mr. Jacob's facility, he will say that, oh, Mr. Jacob now has steady power supply in his facility. He will be very happy for him. However, when he gets to access the system we have given to his good friend, it is at that point in time he will discover that that system has been oversized. So when you are powering up basic clothes, your television, your lighting point, or your fan, you do not need 10 kVA. You don't need it. You should make provision for something that is equivalent to the energy need of that facility. But when you assume, you are going to make a whole lot of mistakes. And remember, if you assume, the cost of acquiring a 10 kVA system, for instance, is not the same with the cost of acquiring a 5 kVA or even a 3.5 kVA system. So that is the analysis behind energy audit, generally saving you costs and preventing oversizing of your system. So when you know the energy requirement of a system, you actually go directly to give your client what is necessary, what is needed to power up that facility, and not just assuming and not just oversizing it, which is going to cause a whole lot of problems along the line. Now, when we talk about safety, we are going to discuss safety on a broader level as we proceed in this training. Okay, so the last paragraph here tells you that solar energy audit links the energy needs of a facility to the sizing of your various solar components, to the sizing of your solar component. So you can see what we have been saying all along. That is what we have been talking about all along. Now, when you are to run a or when you are to run an energy audit on a facility, when you are expected to carry out an energy audit on a facility, there are certain things you need to look at. There are certain things you need to put into consideration. One, the list of electrical appliances to be powered by the solar system. Two, the power rating of the electrical appliances in watts. Three, the daily running hours of the appliances. And four, total energy consumption of the building. These are the things you really need to look into, the things you really need to see how you can be able to use them, to make good use of them in sizing your the energy need of your facility. These are the things you really need to or rather those are the things that will guide you to really size the energy need of your facility. The list of your electrical appliances, the power rating of those electrical appliances, daily running hours of those electrical appliances, and the total energy consumption of the building. At this point in time, you may not have to worry so much about the application of all of these considerations or parameters. But in a later level, as we proceed in this training course, you are going to be taught how to apply these things. And when we get to that stage, you will see the application level and then get to understand them. Importance of solar energy audit. It provides the data needed for the appropriate system designs, helps you identify opportunities to reduce energy use. It helps to reduce the capital cost, and it will help to ascertain the backup time of this solar storage. In all, solar energy audit helps you or prepares you for energy management. As an installer, one good thing you need to know, one thing you need to put in your heart is proper energy management, is teaching your client proper energy management. When when an appliance is not in use, it should be turned off. Your system should be sized the way it should be sized. Nothing should be left behind. Proper energy management is the secret to keeping your solar system running efficiently. Now, safety. Remember when we said there are things that the energy audit does for you? We said that energy audit helps you to prevent oversizing of your system. It helps you to safeguard your uh, appliances and your solar system as well. It also helps you to save you costs, right? We have talked about saving you costs and the other guy preventing oversizing. Now it is time for us to talk about safety. When we talk about safety, we are talking about keeping the entire solar system safe and your home appliances. Yes, the entire solar system must be safe. Your home appliances should also be safe at the same time. For you to safeguard your solar system and your home appliances, you need to make use of safety tools and gadgets. You need to make use of safety tools and gadgets. And these safety tools and gadgets are of various types, are of various kinds, are of various brands. Okay, you have them such as your fuse, your surge, your breakers, your earthing, your grounding. Some persons would ask, or there has always been questions such as, Sir, how important is earthing in the solar system? Sir, can we ground the solar component? Yes, those are very good questions. You can actually earth, you can actually ground your solar component, because this will prevent fire outbreak, overloading, overvoltage, undervoltage, lightning effect, or even shock. However, the key thing to take away from this lecture right now is that um, yes, you are allowed, you are advised to safeguard your solar system. However, there are two parts when it comes to the solar system. Yes, there are two parts. You have the AC part and you have the DC part. So does your safety tools and gadgets. That simply means that your safety tools and gadgets are also in two modes. You have the AC safety tool and gadget. You also have the DC safety tools and gadget. On no account should you use the AC safety tool and gadget for your DC side. The same applies to you using a DC safety tool and gadget for your AC side. It is not allowed. That is going to cause disaster, chaos in your system setup. You know, most technicians would claim to be solar installers. Please, when you meet such people, do not argue. All you need to do is to put them on their toes. Put pressure on them to really explain to you how the solar system works. To explain to you the solar system component, the solar system makeup, characteristics, and its components. Most technicians will use AC cables for the solar system installations. Please, that is very, very wrong. The cablings you are to use for your system installations are not the same ones you use for your AC wiring. We have what we call the DC cables, and they must be sized the right way. They must be sized properly before you can say you have uh, done a perfect and efficient system setup. On my screen are the safety tools and gadgets. Most of you are very familiar with it. These are your breakers, your fuse, your surge, your changeovers. What is this? Automatic changeover. Um, you also have your other gadgets there. Voltage monitors are there. For the breakers, do you know there are various types of breakers? There are various classes of breakers, and there are various sizes of breakers. In this training, we are going to walk you through that process. However, for this basic course, we are limiting this training to helping you know and understand how to design a solar system for a residential level. But then we also have an advanced course for this solar, which will enable you design your solar system in a large scale one and give you the flexibility of designing the various sizes of each and every of these your safety components. That is to say, you will be designing the right size of breakers, right sizes of fuse, right sizes of cables to be used for your system setup so that your system will work efficiently. So this is your PV box. This is your PV box where you have your cables, your breakers, your fuse, your surge. You might have a very good idea of this, but then if you do not know how to handle this box, that is one of the this can any error that is occurring in this box can lead to so many things, even such as fire outbreak in the solar system. I have a video I will be sharing later on about cabling, wiring of your solar system. When you guys see it, you will remember when I said I have a video to share. In fact, that job was done by someone else, and I think maintenance was supposed to be done by a new personnel. When that new person got there, he became confused because he cables were scattered all over the place. So these are the things we teach you on this our very platform. All right. So we have been able to complete the very first phase for this training session, for this training course. And we know that at this level, there will be questions and answers. All right. So when that time comes, we will also take questions and answers on this very platform. All you need to do is to tell us your name and your location, and we can uh, go ahead to take your questions. Please, there are rules on this platform, just as there are rules on every of our platforms. If you are in a very noisy place, it is a very simple rule, please. If you are in a noisy place, kindly mute yourself and use the chat box. If you're in a noisy place, kindly use the chat box to send in your messages. But if you're not in a noisy place, you can actually unmute yourself and talk to us. Tell us your name and your location, and you can go ahead to ask your questions. All right. Having said all of that, let us take the first phase of questions now. Anyone who has a question, touch your screen, touch your microphone, and then you can ask your questions, please. Are you guys there? Is anyone talking to us? Anyone asking any question? Or do we go ahead? Are you finding it difficult to unmute yourself?
Hello.
Yes, go ahead, sir.
Yeah, my name is Gettizer from
Okay.
Malawi. So from seems like most of the guys we don't have like questions, but if it's possible, it's just feeling that maybe you have to continue at least to understand better from there. I think we can have more questions since we feel like just had just few minutes. Some of the people maybe that are calling since you started up now. So if you get it from now, maybe you can have something. So just wanted to add on that if possible.
Okay, so since there are no questions, we can actually proceed. We can proceed. All right. So, for the purpose of tonight's class, we are going to be looking into what we call electrical load analysis. Electrical load analysis. What is electrical load analysis and what is its importance in this training course? Electrical load analysis is a calculation, series of calculations, the processes of evaluating the energy needs of a facility. Remember when we said you are to get the energy need of a facility? Yes, I believe you all remembered when we made that statement. However, we didn't tell you the means through which you are expected to get this system design. Now, electrical load analysis is that means. That is the procedure. Electrical load analysis is the tool which you are expected to use to calculate, to size, to design, to know your energy need of a facility. This electrical load analysis shows you or gives you the exact energy consumption, that is wattage, of your specific facility. We have been talking about getting to know the energy need of a facility, and we have also said electrical load analysis is that which would help you to get that your energy need of the facility. However, before you can carry out electrical load on any facility, before you can carry out an electrical load on any facility, you have certain questions to ask. There are certain questions you should ask. There are certain questions you are expected to ask as a professional. Okay, so you are expected to ask two professional questions, two important questions, two very vital questions, and a third one as a bonus. So it's actually three questions, but two are more important and more professional, while the other one is just a supporting question. Okay, so the very first question you are to ask when you are invited for a solar system project is to find out the energy requirement of that building, the energy need of that facility. Now, let's say again, Mr. Jacob is our client for tonight, and he has invited us to run a solar system for him in his facility. Running a solar system for him in his facility has to do with us going for site survey to really know what he has. So, as professionals, on getting to Mr. Jacob's facility, the very first question we are to ask him is to know his energy need. So, if Mr. Jacob is a new person to solar system, if he's new to solar system installations, he might tell us he does not understand what energy need is. We will then break it down for him by asking him to give us the list of the various appliances he intends to power up using the solar system. Now, giving us the information, he will then say he wants to power up his TV, his freezer, his refrigerator, his microwave, his air conditioner. We will take note of it. We will then ask him the second question. What is the backup time for that solar system? What is the backup time for that solar system? Now, this backup time has to do with the energy storage or energy stored in the battery system. The backup time tells you it tells you how long the energy stored in the battery system would run. When we talk about backup time, it simply means that we are now familiar with the source of solar energy supply, which means that the solar panel absorbs the rays of the sun and converts it to electricity for us. However, the sun does not stay up all day, but then there might be times that Mr. Jacob might need electricity in his facility. And when that time comes, what will he do? Engineers came together to say, okay, we can actually create something that can hold energy together when the sun is up and running. And when the sun is no longer up and running, you can now depend on that thing we have designed for you. That thing is called the battery or the battery bank. So now the battery has now been included into the solar system setup, so that when the sun is up running at its peak, the solar panels will harvest this energy, use it to power Mr. Jacob's house, and then store up some of the energy in his battery bank. And when there is no more sunlight, he can now be able to use the energy that has already been saved up. The big question now is, how long can that energy stored in the battery bank last for Mr. Jacob? That is what we call the backup time. That is what we call the backup time. So it is in hours: 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, even 24 hours. One thing you need to know as a professional is the the higher the backup time, the higher the cost of installing that system. So if Mr. Jacob says he wants a system that will run for 24 hours, it means that he should be ready to spend a whole lot of money. So now we have asked the two professional questions: energy need and backup time. It is now time to ask the third question. So this third question comes as a means to save us the stress of going through rigorous process that will not yield any fruit. That simply means that on getting to the facility, you have sized your client to say, okay, this man can actually afford these things, this man can afford to pay for this thing. So if you have sized him to say and you feel he might not be able to uh, carry out that project, please, you need to ask your client his budget. Asking your client his budget is not a crime at all in this field. It is going to save you the stress. It is going to save you the time. It is also going to put you on track to give him what he can actually afford. So let's take, for instance, Mr. Jacob has given us his energy need, and we see that his energy need is like 10,000 watts, and his backup time is like 15 hours. Altogether, Mr. Jacob is needing something like 50 million kwacha, and we know that Mr. Jacob can only afford 10,000 kwacha for that project. Do you think it is intelligent for us to go ahead to size that facility? No. Do you think it's wise for us to continue work on that facility? No, no. So that is why we said once you have reached this level, you need to ask your client. So we ask Mr. Jacob, please, what is your budget? Mr. Jacob then tells us, oh, he has 30,000 kwacha for it. At that point in time, we will take a pause and then ask and then advise him, not even ask, advise him on the next line of action to take. We will advise him on the next line of action to take, because, like we rightly know, the available budget cannot be able to take care of the system installation. So we'll give him what he can afford at the moment and then make provision, adequate provision for upgrades. Yeah. So, importance of electrical load analysis. It ensures proper sizing of your system. It prevents overloading. It prevents fire hazards. It improves safety and efficiency of systems. It improves safety and efficiency of your system. Now, taking a good look at this table is what we call a typical example of electrical load analysis table. Electrical load analysis table. So take a very good look at it because you are going to be working on it as we progress in this training. Remember we said electrical load analysis is the tool that helps you to know the energy requirement for a facility. Now, we are putting it in a tabular form so that it will easily represent that or pass that message or give out that information we are trying to give out. Now, before you can carry out electrical load analysis on any facility, there are important parameters you must take into consideration. There are important parameters you must take into consideration. Very important parameters. One, the quantity of appliance. Two, the power consumed by the appliance. Three, the running time of an appliance. Now, the quantity of appliance typically tells you or clearly informs you of um, the number of available appliances that the client intends to power up using the solar system. Let's take for instance again our client for tonight, Mr. Jacob. Let's say he lives in a three-bedroom apartment, and in that his three-bedroom apartment, he has three TVs in each of them. However, for this solar system he wants to install in his facility, he's only making provision to power up two TVs. So on our table of load analysis, we are only going to be including two TVs. So for the quantity of appliance, it simply tells you how many of the same appliance the client intends to power up using the solar system. Now, the power consumed by the appliance. The power consumed by the appliance tells you or informs you the rated wattages of each and every appliance. The rated wattages of each and every appliance. Now, how do you know the rated wattage of each and every appliance? This, this is gotten from the nameplate of those appliances. This is gotten from the nameplate of those appliances. The nameplate is that place on the body of that your appliance which gives you or states clearly all the information concerning that your appliance. The nameplate can contain the maker of that your appliance, the kind of product it is, the serial number, the IMEI number, the country of make, the voltage, the current, and the wattage. So those are the details that you would see. So you just go to that nameplate and harvest your wattage, which is now the energy consumption of that your appliance. Now looking at my screen clearly, you will see a nameplate. What you are seeing, that image you are seeing there is a nameplate. I want you all to look at it clearly. Can anyone or is there anyone who is seeing it clearly who can tell us the energy consumption of this LG TV? Is there anyone who is seeing the picture clearly who can tell us the energy consumption of the TV? You can use your hand to zoom it in. Unmute yourself to tell us the energy consumption of the TV or use the chat box to send in the answer, please. Is there anyone? Mr. Jacob, can you see the energy consumption? I cannot hear you. Touch your screen and touch your microphone.
Hello.
Yes, go ahead, Mr. John.
Yeah, I can see the energy consumption is 120 volts, that is alternating current,
What did you say?
and 195 watts.
So,
I can
okay.
see the energy consumption being 120 volts and 195 watts.
No, that is not the energy consumption. Is there any other person who can give us the exact energy consumption? The exact energy consumptions. Mr. John, you are on the right track, but you are not. But
50
you're
to
trying to
60
confuse
hertz.
us. Okay. Any other person? Go ahead.
50 to 60 hertz.
No, that's not the energy consumption. That one is frequency. Okay. Tell us who else can give us the energy consumed by this appliance. Just unmute yourself, touch your screen and touch your microphone. Just one value there is the energy consumption, not two values. Just one value there is the energy consumption. Okay. So,
194,
Mr. Gift, you said what?
195 words.
Thank you. That is the energy consumption, 195 watts. That is the energy consumption. So, Mr. John, you can see your error. Okay. That is why I said you were on the right track. However, you are trying to confuse us by bringing in the voltage. The voltage is not the energy consumption. The energy consumption of anything is a function of voltage and current. But for this appliance you are seeing here, you already have the energy consumption in watts. So you should have just given us that 195 watts and we can move ahead with it. Thank you all for participating in that. I love that activeness. Thank you so much. So, running time of an appliance. The running time of an appliance tells you or only takes effect when those appliances are powered up. When those appliances are powered up, okay? So it means that how long does Mr. Jacob intend to run those appliances, intends to power up those appliances? That is what we call the running time of an appliance. Is it 1 hour? Is it 2 hours? Is it 3 hours? Is it 4 hours? Is it 5 hours? What you need to know is that the higher the running time, the higher the cost of installation. So that is just it. Now we are back to this R table. This is where you should get serious with the training because this is actually the very first system design you will be encountering before you go into the uh, full system designs properly. So on this table of load analysis, we have already stated out all the parameters that are needed for load analysis uh, uh, table design. Okay, so you can see the quantity of appliance, the power consumed by the appliance, and the running time of that appliance. Okay, yeah. So on this very uh, table of load analysis, it is assumed that our client for tonight, Mr. Jacob, has invited us to run a load and to run a solar system for him in his facility. And on getting there, we have asked him that very first question: what is his energy need? And he has provided us with these five appliances to be powered up. These very five appliances to be powered up. And this are what you can see on my screen. Please, this is the point you can write. And this is the only time you can write for free. After now, you might not be able to write, even though our clients can volunteer to pay for some persons after this class. We don't know, but then it is only those who pays for the class that would continue, and complete the class. So you can write this information down. So we are now going ahead to design to know the load analysis or to know the energy requirement for this facility. This facility is going to is housing 5 appliances, or rather the solar system is going to be powering 5 appliances: DVD player, light bulb, ceiling fan, refrigerator and blender. Okay, so before we go ahead, let us take the details of the appliances just as you can see on my screen. For the DVD player, the quantity is 3. The power consumed is 100 watts. The running time is 1 hour. For the light bulb, the quantity is 1. The power consumed is 100 watts. The running time is 2 hours. For the ceiling fan, the quantity is 10. The power consumed is 10 watts. The running time is 24 hours. For the refrigerator, the quantity is 3. The power consumed is 10 watts. The running time is 4 hours. For the blender, the quantity is 1. The power consumed is 80 watts. The running time is 1 hour. So we are now going to run a load analysis on these appliances. We are going to be running a load analysis on these appliances, just as you all know and are aware. Just as you all know and is aware of it. So what do we do right now? There is a formula for it. That formula states that energy consumed is equal to quantity of appliance multiplied by power consumed multiplied by the running time. Quantity of appliance multiplied by power consumed multiplied by the running time. That gives you the energy consumption of the facility. Yes. So now how do you apply that? You apply that formula in such a way that you get the energy consumed by each and every of these appliances, sum it up. That is to say, add the whole individual energy consumptions up to give you the total energy consumption. Let's go. For the DVD player, 3 multiplied by 100 by 1 gives you 100 watt hour. For the light bulb, 1 multiplied by 100 by 2 gives you 200 watt hour. For the ceiling fan, 10 multiplied by 10 by 24 gives you 2400 watt hour. For the refrigerator, 3 multiplied by 10 by 4 gives you 120 watt hour. For the blender, 1 multiplied by 80 by 1 gives you 80 watt hour. So altogether, 300 plus 200 plus 2400 plus 120 plus 80 gives you 3100 watt hour. 3100 watt hour, and that becomes the total energy consumption and the energy need of the facility, just as you can see on this very table. Just as you can see on this very table. So with this, you have been able to design to know the energy need of Mr. Jacob's facility. We have been able to design to know the energy need of Mr. Jacob's facility. And from here right now, we have made progress one step ahead. Questions, please. All right, questions, please. Questions quickly.
Okay, I have a question.
Talk to us, please, sir.
What if we have, let's say, an inverter maybe in this circuit that is AC current and DC current? How do we come about it? Yeah.
I can't really hear what you said, sir. Is this breaking? Are you using an earpiece or connected to an external speaker? You need to disconnect so that your signal will be smooth. Talk to us, Mr. John.
Okay, I'm asking,
Mm-hmm.
suppose you have an inverter in the circuit, let's say that is alternating current. Will you use the same method to get the total current? That is the direct current and the alternating current. Yeah.
I don't still understand the question direct current and alternating current for your inverter. What really do you want to know about direct
Hello.
current and alternating current, sir? Mr. John, can you take the question again so that, or you can you break the question down so that I can understand you? 'Cause I'm not really understanding what you mean by alternating current, direct current when it comes to the inverter. Is there a way you can break the question down for us to understand? Mr. John, are you there?
Yes, let me write the question.
Okay, please do, please do. Okay, so go ahead, Mr. Is it Sholocks? Go ahead, since tell us your name and your location, please.
Hello.
Your name and your location. Please, if you are using an earpiece, you may need to disconnect it because if it's not compatible with this online meeting, it is going to be making a noise.
Okay.
So disconnect and talk to us. Talk into your phone, please.
Hello, sir.
Yes, go ahead, please.
Good evening, sir.
Yes, good evening.
Yes, sir. My question is, now that we get
Your name and
3,100 watt now,
locations.
how
Your
do
name and location, sir.
my name is Solix Global Constant from Ogun State.
All right, go ahead.
Hello, sir.
Yes, go ahead, please. Go ahead, please.
Yes, sir. What I'm trying to ask is this: now that we get a total of 3,100 watts now,
Mm-hmm.
how do we know how many battery and how many solar panel and how many inverter? I mean, the total watt of the inverter that we're going to use.
Okay, very good. So you are trying to know the size of the inverter, panels, battery, charge controllers. That is what you want to know. We are going to go into it and we will design to also
Yes, sir.
know those sizes, sir.
Exactly, sir.
All right, thank you. Any other question or questions from what we have learned so far, so good, please? You can unmute yourself and talk to us, but if you're in a noisy place, kindly remain muted. Go ahead, Mr. Gift.
Yes. Can you tell me about the chat we had before
Mr.
communication, if
Gift,
possible?
are you using an earpiece? I can't really hear what you are saying.
Anna, I'm not using it. Maybe it is not, but what I'm trying to say is, when you tell me about the chat we had before, each of the calculations before if possible.
Sorry, sir, I can't hear you. Can you put your question in the chat box? I can't hear you at all. In all honesty, I can't hear what you're saying.
Okay, what I'm trying to say is,
Uh-huh.
are you getting me?
Okay, go ahead. Let's try again.
Okay, each of our calculations, of course, I'm not good on the mathematics, but actually, I was just merely trying to understand what was on the chart. So what I was not understanding was like we had the per point. Let's say we have three bulbs, right? That is consuming. Is it 10 watts? You have that kind of calculations whereby item quantity, those kind of. So what I was trying to say is you were putting like we have TV, three TVs that are consuming that will need 100 watts. So when the one time was you are multiplying with actually I'm wrote because there's no chat there. That's why I was asking for the chat just to get my question clear. So I don't know if it is possible.
Mr. Gift, in all honesty,
Yes,
I couldn't get what you are saying. Are you confused about the parameters to use for the designs, or what is the challenge? I didn't hear anything you said, in all honesty. Oh, okay. Is there anyone on the platform who heard what he said? So you can um, let us know so that we can attend to the question, or use the chat box, sir. I can't hear you at all. There's something wrong with your connection.
okay then okay fine. I'll get back to you later then.
You can write it in the chat box and we can take the question accordingly,
That's
because
fine
I
then.
can't hear you. Your mic is as if something is covering it, so it's not loud.
Oh, sorry then.
Yes. So, any other question or questions before we proceed? Any Mr. John, are you done writing your own question? Maybe we can take it before we proceed.
Okay, let us proceed. I've not finished.
Okay. Okay. All right. All right. All right. Please, Mr. Sholox, I muted you before. Kindly mute yourself, please. Since you're not asking any question, kindly mute yourself because of the noise from your background. Thank you. All right. So, proceeding. Proceeding, we have been able to do justice to this very course in this session, to the topic energy audit. We have been able to introduce it to you. We have been able to show critically give you guys the parameters that are to be considered when we talk about system sizing. And we have also talked about the application of those parameters. Yes. And that application has to do with you having a very good idea of the electrical load analysis. However, this is where we are now informing you that the training has come to an end. This is the end of the session. This is the end of the session, and now you are being asked to enroll fully for this course. Enrolling fully for the course is what we call the premium class. That premium class is what will offer you access to continuing and completing the training course. Just as Mr. Sherlock asked, how is he going to be able to size the various solar components? That simply means that he's aware that this training is not yet over. It is not yet complete at all. Yes, even though we have given you a lot of knowledge, a lot of information already by helping you to know your energy need, it is just like you being half baked, because in energy audit is the link between the energy requirement for your facility and the sizing of your various solar components. So if you only know one part and you don't know the other part, you are still going to mess up yourself in the field. So now is the time you all are expected, you all are required to pay your enrollment fees. And when you pay your enrollment fees, it guarantees you attending the classes completely. Now, attending those classes completely means we are not going to be attending live classes such as this one. You are also entitled to getting the complete training materials, which is the PDF that most of you have always asked us of. So this calculation is also in that PDF. Okay, it is also in that PDF that we will give you access to. You will attend live classes, we'll give you the materials. Even if you miss the classes or you're having network connectivity issues, you cannot contribute, at the end of the session We will also send the recorded videos to you. Also, paying your enrollment fee guarantees you or opens you up to mentorship program that we have for you. That mentorship has to do with if you are in the field and you face any challenge or challenges, you can easily come to us and we will give you first hand, first class information till your problem is resolved. As long as it is within the frame of this basic course. If it is above the basic course, we will tell you what to do while we try to assist you to achieve your project. I hope you guys are following up. Some of the fees have already been mentioned, or rather, all the fees have been mentioned. Nigerians are paying 5,000 naira, Ghanaians are paying 300 Ghana cedis, Cameroonians are paying 8,500 Cameroonian sefa, Zambians 300 Zambian kwacha, Ugandans 45,000 Ugandan shillings. Please, if you are here, you have not heard your amount and you don't know how to pay, that is the means, the method to pay. You can let us know. Some are paying through direct bank transfers like Nigeria, um, Ghana, Cameroon, Zambia, they are all paying through Momo. Even Uganda, paying through Momo. Namibia, you're paying through our online payment platform, you're paying 10 USD. So if you are here, you have questions on payment, let us take them quickly before we call it a day. Okay, South Africa, you are paying 350 rands. South Africa, you are paying 350 rands. Any other question on the payment? And if you want to make your payment right now, please text me privately. Okay, Kenya is 2,100 Kenyan shillings. Malawi is 55,000 Malawian kwacha. Okay, 55,000 Malawian kwacha. So, Kenya, Malawi, South Africa, we are not receiving directly from you guys. We are paying to agents in your countries, okay, and they will route those money for them to get to us. So we will be sending you those details. So you can text me privately to we'll give you the details of the payment details rather to make the payment so that they will help you process it to us. Okay, any other question on the payment? Now, Mr. John is asking if I get a client who has a circuit with AC and DC circuit, how do I get the total energy? That is very simple, sir. Both your AC circuit or appliance or your DC circuit or appliance, both of them have energy consumptions. So you can decide to do it DC circuit design separately, AC circuit design separately. There is no problem. It all depends on your system designs. You also know that you have flexibility of connecting your DC circuit, that's the DC appliances, directly to your solar side of your solar system, which means you might not be connecting your DC circuit to your inverters. I hope you remember the work of your inverter. It converts your DC energy to AC energy, okay, and then power up your AC appliances. So for your DC circuit, you might not need to connect it to your inverter. So you just create, you just so what you need to do is when you are now considering your DC appliances, you might be considering the effect on your battery system and not your inverter system, okay, because you might not be powering them up with your inverter. So you can power them up with your battery or your charge controller so that it can take the energy directly from your solar panels. So for the technicalities involved in all of this, you need to enroll fully for the class. Sir, you haven't answered my question. What is your question, Mr. Sherlock? You asked us to give you the how to size the inverter system, charge controllers, batteries, and you said we did not answer it. We said you need to enroll for the class fully. That is what we said, sir. We have answered your question, sir. We cannot give out that answer to this class. So if you have paid your enrollment fee, you don't need to bother, because in the next class, that is what we are going into. So that question has been taken care of. So you need to pay. You need to pay your enrollment fee, sir. Thank you so much. Any other general question or questions? Okay, Zambia, you are paying 350 Zambian kwacha. Okay. Sorry, 300 for Zambia. Zambia, so sorry. 300 Zambian kwacha. Okay. Before you guys will fight me. Please forgive me for that error. It's 300 Zambian kwacha. Okay, please report the account details on. Okay, no problem, sir. Okay, for Cameroon, you are having challenges making the payment. No problem at all. So what you can do, Mr. Ndowo Robinson, please text me privately right now so that we can take up this your case. We have Cameroonian number we can give to you, since you cannot make Momo payment, and we can even, if you are using Momo, we can guide you on how to make a payment. It's very easy. Okay, so technology has made things very easy, so you don't need to disturb yourself or anyone else. So just text me privately right now, and we can take it up from there, sir. All right. For the account details, you can also text me privately, so that we will give it to you before we put it up on the platform. Are we training for SPV1, SPV2, or SPV3? I do not even know what that is, Mr. John. So you have to talk to me privately. If you have that method in your country, you have to explain it out clearly before we can now know the answers to that. All right. Okay. So if there are no other questions the concerning the payment methods, amount, and anything concerning the training, this is where we shall be calling it a day on the training. We love your commitment, we love your presence, we love your activeness, we love the audience we got for today's training session. And we want to also see you all progress to the next phase. And that next phase begins tomorrow, and it will hold with you. Please do not miss that class. The next class is tomorrow, sir. Just like I just said, the next class is tomorrow. The information will also be shared. Okay, please and please. This is one thing for you all. One good information for you all. As you're on our platform, we try as much as possible to update you guys. Okay, so if a training is to start in the next 4 hours, we will put up a notification the training starts in 4 hours. That means if you calculate the time that information came to you and the time you are currently, you will know when the training will start. So your time zone does not even matter at all, because when the if we send it here in Nigeria, the time in Kenya is ahead of Nigeria. It will drop at that exact time in Kenya. So if we say 4 hours time, so your time in Kenya, add 4 hours to it, you get to know when the training will start. So these things are some of the things you should put at the back of your mind, so that you don't keep repeating and asking the same question over and over and over. Okay. All right. Thank you so much. See you all in the next training session, which is tomorrow, please. It is starting tomorrow. Have a wonderful night rest, everyone. Bye bye.